Hey everybody. Hi, welcome to another episode of Curated Reality. This week's been different. We have like been the first talk where we have a different time zone altogether involved, and we change our times as well. This week we really wanted to talk to Nate about a couple of things. Before we even get into those things, right? I just wanted to give a slight background as to what how Nate and I first met, right? That was very interesting. Like I ran into Nate, I think 6 to 7 times in the last one and a half year in at multiple different conferences, and that is how we actually became friends. Like the first time I think was at DroidCon Boston way back in 2018, and that time we just had hardly spoken like hi hello type, and then but then after that in the next 2 years, like 2018 and 2019, we kept running into each other at random conferences, and like it kind of became a tradition that we kind of run into each other like that across the year. So that is how we kind of got together. So it's been fun that way. Uh, Welcome to the channel. We are glad to have you here today, Nate.
Yeah, thank you. I'm excited to get to join in with both of you. Happy to get one one chance to kind of connect this year without our typical like conference circuit. Um,
Right.
it's been nice. That's been the I guess like the one small saving grace like the virtual events is you know seeing some people even if not face to face, seeing them at least through the computer has been kind of nice.
Right. So, and yeah, as always, we have Vedant with us as well.
Yeah.
Vedant, say hi.
Hello. Hello.
Cool. So, uh, even before we start, right? Like we kind of had informed everybody that what we will be talking about, just to give them an idea. And before we get into the details, right? I wanted to understand like why did you have been working very closely with build optimization and all of performance and CI in general over the last 2 years, right? Like you have been speaking about it, blogging about it quite a lot on every place. Why choose that specific stream? Like what started that in interest in that particular this, right? Because it is a very different stream from your day-to-day kind of a Android developer kind of a thing, right? It is more about DevOps and build optimization and performance and things like that.
Yeah. There's a few interesting bits to that. So I think like the reason I sort of became interested in it was because my first job out of university, I came into a team that was sort of like a weird hybrid of like a modern sort of like very agile team. Um, Within like a very large organization. And so one of the things that came with that is like we had like this dedicated sort of DevOps sort of like QA team. And so we had a lot of really great build processes and things that were all automated for us. So I just like I sort of like was trained very early into like my first professional role that like you want to have an automated build, you want to have like automated testing, like you don't want to be like building your app locally and like using that as any kind of source or truth, because like you very quickly start running into issues with that. And so I just like got used to that. So when I started my second job, which would have been I was at Udacity, I got there and like we didn't have a build. There was one, like there was a configuration file for a build, but like it didn't work. Like just like it would like run like periodically and it just like would fail every time. And so like one of the first things I did was just like I wanted to fix that. Like I wanted to get back to this idea that like we could have this stuff running, partly just because I was trained that way, partly, looking for like ways to quickly like make an impact, joining a new team. It's always nice to be able to like, have some quick wins. So anyways, like that just started me down this path of like learning more about like automated builds like CI, CD, learning more about that process. And so that continued while I was there at Udacity. That continued a bit at my next role after that. And so anyways, now in my current role, again, I came into our team and um, my coworker Roger had been looking at working with Gradle Enterprise. So Gradle, everyone, Android developers generally familiar with Gradle as like a build tool,
Right.
Right.
but I think sometimes it's lost that like Gradle is also this company, and they have like enterprise level sort of service offerings, which is Gradle Enterprise. And so Gradle Enterprise is sort of this this means of like capturing build scan data for your app, and helping you gain insights from that, and we can talk about some of those processes if we want, but basically like he had just started this process of kind of working with them, and they were helping us like optimize our build and whatnot, and just having had that background of like CI CD, trying to make builds faster, trying to make our CI pipeline more stable. I just sort of like jumped in. I started asking like if I could be added to the meetings, and then we quickly found that like there was a lot of work to be done for us, and so the two of us were tackling this, and so now it's been like actually a really large part of what I've been doing in the day to day for the last several months now, or even really probably 4 or 5 months. And so it's just been sort of like this long sort of path for me of like doing little things here or there, getting a little bit more interested, learning more about it, and then like you mentioned, I've been kind of sharing about this in some of my talks and blog posts, and I think that has largely just been because it's easier to share the stuff that you're sort of already doing. Like it's hard to like have your day job and then do all this other stuff outside and then also come up with
Right.
talks or posts. And so as much as possible, I always try to just like share what I'm doing within work if I can. And so that has been a big part of what I've been doing, is like sharing like optimization, like build optimization tips, automation, tricks and stuff for GitHub, things that we were putting into place in my team. And so it's just been like this path of like a little bit like conference driven development, a little bit of like team needs, and it's something I really enjoy. I find myself, the more I'm doing with it, the more I want to do with it. So I'm sure it'll kind of continue. I really appreciate like build optimization and profiling, because it's measurable and like actionable. It's if you might spend a couple sprints working on a feature, ship the feature. If you're forward thinking, you have an idea of how you're going to measure the success of this feature, but like it's hard to know if whatever you shipped is actually like working or bringing value, and if you ever get that answer, it's usually like a long lag time. But like with build optimizations, it's nice. Like you can profile your build, find some bottlenecks, fix them, rerun the benchmarks, and see like, oh yes, I just increased build performance by 10%, and then I can kind of estimate a cost savings for that. And so there's something just like very gratifying about that. And so like I always seem to be like keeping these like little build tasks in the background, just as like small little wins for me, and then obviously they help the team. So it's turned into something I really enjoy, and I find a lot of benefit in it, for our team, particularly in this current role. We've seen some really nice wins from a lot of this work we've been doing.
Right. Interesting. Like when we talk about builds, optimizations and performance, right? For most of the teams out there today, right, it is even I am like guilty of this, to be honest. Like it's not that I'm any different. It's always like an afterthought, right? It is like in a place
Mhm.
wherein, hey, let it reach like 100 odd modules and then let it take like an hour to build. That's when we'll start thinking of all of these things. Like don't fix it if it is not broken, kind of an attitude, right? How would you recommend, like what would in your opinion is the best time to get started in terms of, let's say you build a new product today, right? And would you do it from start itself, or would you wait till you, like what was the ideal way to get started? When would you, how would you recommend going about that?
Yeah, I would definitely get started at the beginning. Like if I was going to sit down and build a new project today, I would be thinking about the build times and build optimization from the beginning. And not that like you're gonna run into like huge issues necessarily. Like if you have a reasonably fast computer, then until your project really starts to grow a bit, which is like a single dev or just like a couple devs, it's gonna take a while. Your local build times are gonna be pretty fine for a while, and even your CI build times are gonna be pretty fine for a while. So like if you weren't doing it, it's not really the end of the world. um, but on the flip side of that, like there are a number of like very sort of easy to implement types of optimizations that can be done that have like really non-trivial positive impacts on build performance. So it's one of those things where like, yes, like you would probably be fine without it, especially like, a lot of us, like you mentioned, a lot of teams don't think about it. And so we're just like accustomed to 45-minute build times on CI. Like that's just like a normal thing for a lot of teams. And it's not until you realize that like, oh yeah, that 45-minute build time could be a 10-minute build time that you start to realize like, oh, like, maybe it is like, maybe we could be doing better here. So I think doing it from the start and just like getting into that habit is good, because I think once you're sort of into it, once you're accustomed to some of the benchmarking, profiling, just getting used to checking in on it, I don't think it's necessarily a ton of work. It's not something that like we check every day to make sure the build times. It's something, we can go and we can check once a week, once a month. Like, what are the trends here? Are there any new issues that have been introduced? It took us a while to get there because we had years of sort of like legacy stuff to catch up on.
Right.
Right.
Yeah.
So, for example, if I have an existing app, so before going into build optimization, we have to profile our build time, right?
Yeah. Yeah.
So how do you approach this thing? Is there any tools we can use?
Yeah, absolutely. So there's, if we're thinking, like a traditional, Android app that's being built with Gradle, or any Gradle based project, because Gradle can be used for lots of different types of projects.
Right.
There's really like two sort of primary tools we have at our disposal. So the first one is sort of like the Gradle build scans. So a lot of people are actually kind of becoming more familiar with the idea of a build scan now, actually, with Android Studio, I think 4.0, because Android Studio 4.0 integrated sort of the like build analyzer tool. So you can kind of run a build and you can see like it'll provide you some output of like, how the task execution broke down, the timing around it, some things like that. Well, that's effectively what a Gradle build scan can do for us. You can basically pass the, I think it's like dash build scan flag to any invocation of your Gradle wrapper, and generate a scan for whatever the task is. So if you're running your test task or your assemble task, you can generate a build scan. The build scan then is effectively like this interactive web page that gets generated for you that totally, like, it gives you a full breakdown of everything involved in your Gradle build. So it will tell you how many tasks were executed, how many tasks were up to date, how long they took. It will give you information about the performance of the build cache. Did you have local caching enabled, remote caching enabled? Where were your hits and misses coming from? It just gives you a lot of like very in-depth information into what's going on when you hit enter and you start that assemble task. And so like if you want to know like how fast is a build, an arbitrary build, but then actually go in and say like, all right, well, if this build takes 5 minutes, what is taking the 5 minutes? Is there one single task that is misbehaving that is taking 90% of the build time? This can show you that. So a great place to start is to generate the build scan, look at the tasks that were executed, sort by longest, and just see like what is taking the most time in my build. And a lot of times these days, like for me, when we've been doing that ends up being things like annotation processing ends up being a big one. Or another one I've been looking at recently is there's some like merge resources tasks that are taking a while in our build because they're not being cached the way they should be. So it's running, it takes 30 seconds to run, but because so much else of our build is cached, like that ends up being like a significantly longer task than any of the others. So anyways, like that would be the first place I would start, is just by generating Gradle build scans. The second tool that I've only more recently started using, in fact, I have a pretty large blog post that's like 90% done that I'm hoping to finish today and put out next week. But there's a tool called Gradle Profiler. So Gradle Profiler, it's basically the best way I can describe it is, so if you wanted to get a sense of the average like build time for your application, the way that I had done this in the past, the couple of times I ever needed to do it, is I close out of a bunch of programs on my machine, I go to the command line and I run my assemble task, and I sit there and I wait for it. When it's done, I record how long it took, and then I do it again. And then I do it again, and maybe I do it 5 times or something, but like I try and get some like average of what that takes. And then maybe I want to see like, all right, I just updated my version of Gradle and enabled, file system caching or something. I want to see if this has a positive impact. So I enable the new branch or enable the new flag. And again, I go back to the command line and I run this manually 5 times. I record all the output. Then I have to do some type of statistical analysis on the output to figure out like, is there any significant impact from this? So it's like this very like tedious manual process that, honestly, I rarely ever did, because it's kind of a pain to think about doing that, right? So what Gradle Profiler does, it automates all of that for us, and it gives you means of configuring this process to suit whatever your needs are. So like in a very simple example, like let's say you just wanted to profile your assemble task in a brand new project. You can invoke the Gradle Profiler tool, tell it that you want to do a benchmarking set. You pass it the directory to the project you want, and then the task. And what it will do is it will basically start up the Gradle daemon. It'll run, I think by default it runs 5 warm-up builds. So the warm-up build basically warm up the daemon, you'll get a little bit of JVM caching and stuff with that. And then it'll run 10 measured builds. And it does this all on its own without you having to go in and do this. And so then at the end, it spits out basically 2 artifacts. You get it like a CSV file of how long the builds took and some of the statistics around it. And then you also get a really cool like interactive page that gives you sort of like a bar chart of how long each build took. It gives you mean, median, standard deviation, and all that. So it gives you like a lot of really nice insight into that. And then it's really like it has a lot of power beyond that to let you define complex scenarios. So like the set of scenarios that I sort of walking through in this blog post I'm working on is like, how would you compare the performance of like a clean assemble build, a clean assemble build with local caching enabled, and then an assemble build that is basically up to date, where theoretically, if your build's configured properly, it's not running any tasks if nothing changes. And so you can use Gradle Profiler to define each of these scenarios in sort of this nice like type safe format that looks a little bit like JSON. But you basically define all these scenarios, each scenario can, have custom tasks that you want to run, custom build flags that you want to put in, and you can have it then run all of those at the same time. So now instead of doing, 5 measured 10 or 10 measured 5 warm-up builds, it's actually going to do that 3 times. So it's going to run like 45 builds for you automatically. And then at the end, it's going to give you the output in a format that compares all of them in sort of the bar chart, and then automatically will do the statistical comparison for you. So it'll automatically compare scenarios to the first one. So in this case, like if a clean build without any caching takes 20 seconds, but your sort of up-to-date task with caching and everything takes 2 seconds, like it's going to tell you like, oh yeah, this is statistically significant, this has a huge impact on your build. So you can really start to use that then to understand better, like, okay, if I make a change, like you could automate a scenario that says, all right, like my baseline is gonna be checkout master, run our set of like 3 tasks that we care the most about. So maybe it's a clean, like I said, a clean build, a no-op build, and maybe you want to validate what happens on an incremental build. So you could run that set of tasks with your current configuration, then switch over to your new branch that maybe updates, Android Gradle plugin, the Gradle version. Maybe it enables, like I said, file system watching as a new Gradle property that's supposed to help with build times. So you could enable all those new things, rerun it, and then see like, all right, yeah, like this looks like it has a positive impact, or this has a negative impact. Another scenario where like you might think about this is maybe you're modularizing your app and you want to see like, all right, in this new modular world, we have a lot more modules here, but we're not sure if like they're configured properly. Maybe our incremental builds are taking more time than they should because we have too many interdependencies. You could profile, like you could set up the scenarios for that and then benchmark that. And then as you work on that modularization, you could always go back to that benchmarking and verify like whether or not your modularization process is having a positive or negative impact on your overall build times. So it's a really powerful tool to be able to go back and get really nice, statistically like significant and accurate metrics into what's going on when you change your build. And that has been really interesting to start playing with and start trying to automate to make it easier for our team to use.
Right.
Cool. So once you have kind of like profiled your build, right, you kind of now know what the biggest task you have at Dexter is basically trying to identifying the bottlenecks as to which are the tasks that take the most longest and how can you spread them up, right? While there is no one answer to this problem, right, because it depends from project to project and things. In your opinion, what has been the most common set of problems or things that you kind of did to fix most of the things, right? Like one of the things that I can think of is parallel versus sequential builds and modules, which, as you mentioned, like if you cache those modules and don't change those modules, then you should not really be building them. And if you don't reference them in a way wherein, hey, you know what, everything needs to get built every time you make change something. So how would you, like, let's say you kind of identify a bigger chunk or a bigger task which is taking a lot of time, how would you start to go about in a slight detail as to understand what is going, and how would you try to figure out like the basic steps at least in terms of what to check?
Yeah, it's a great question. So much of what I'm probably about to say, I only learned from working with the team at Gradle, and also Tony Robolik, who's also based here in Seattle, who used to work at Gradle. Like chatting with those people who are really well informed on all this is basically how I have any idea of this. So I just want to put that disclaimer out there because like this is all like new to me very recently on how to really go about this. But like the process I constantly find myself kind of going through now when we run into these scenarios is, we'll start by looking at the build scan. So again, the build scan ends up becoming our go-to tool for trying to understand this stuff. And then generally the first thing I end up doing is, probably sorting by, what tasks were executed, and sort those by how long they took, just to get some idea, like, what is taking a long time here. And then filtering, like trying to figure out which tasks what tasks are cacheable, but were not pulled from the cache. So the idea here is, like, do we have tasks that should be cached, but for some reason are not being cached? And this has ended up being so key for us, because being able to pull something from the cache is such a performance win that has ended up being like the most valuable thing we do, is trying to fix as many of these cache misses as we can. So if you don't, like, if you start a brand new project, you likely don't have caching enabled by default. So if you look at your build scan and you see 100 tasks executed, and then you filter and look for, all right, how many tasks are cacheable but weren't pulled from the cache? If that number is the same as the total, right there, then you have an indicator, oh, nothing's being pulled from the cache, maybe caching is not even turned on. So that would be like the first thing to kind of look at, is like, is there any type of local caching turned on for your project? I think that is like one of the big ones. Then you could turn that on and basically rerun this, right? So now you could rerun this, and theoretically you would have a lot of stuff being pulled from the cache. You might not have everything being pulled from the cache though, especially depending, as your project grows, more and more things are not gonna maybe work as you expect. In particular, like, unfortunately, like the Android Gradle plugin itself has a number of different tasks that like don't cache properly. So like Room, for example, there are some tasks related to Room that doesn't work quite right. There's a merge resources task that I've been fighting with lately that doesn't cache quite right. So you might still find these things in there. So then what we've done, and thankfully the Gradle team made this easier, is we start like just writing down these individual task types and going and looking like, oh, why is this task type not cacheable? And actually, thankfully, there's another tool here that you can kind of find if you do some Googling, or like if you're watching this, you can find it. But it's called I think Gradle. Yeah, I'm trying to search for it real quick here. Gradle cache fix. Yeah. Okay. So for some of these types of tasks that like are cacheable but aren't being cached properly, there's this plugin called Android Cache Fix Gradle plugin. And here, I'll just share my screen real quick.
Sure.
Let me know if you can see that.
Yes.
Okay, cool. So this plugin here is basically, it's maintained by some of the folks at Gradle, and I think maybe some others, but basically like this plugin is designed to help developers get back the proper caching that is maybe missing from the Android Gradle plugin. So like if we scroll down here, integration is super simple. But like this list of issues here, you can start kind of looking through the source code, and you see there's a bunch of different types of issues that this attempts to solve. And like some of them you can see here, like it attempts to fix a merge resources issue. It attempts to fix some issues coming from Room. So it basically tries to work around those somewhat broken tasks. And that has been another big win for us. So that's, I think, kind of the step two. So first step, get your local caching set up, then see which tasks still aren't being cached. Then, do a little bit of like Googling, maybe look for this cache miss plugin, integrate that, then see kind of where you're at with that. At that point, hopefully most of your stuff is being, cached, and you're getting a lot of those wins. You had mentioned, Adnan, parallel execution of your builds. That's another one.
Right.
Enabling some of these Gradle build properties, like I said, like the local caching, like the parallel execution. There's some new ones like file system watching. There's some of these things that Gradle are doing as they continue to work on the tool that are specifically designed to improve performance of this stuff. And I'm just trying to pull a couple of those up right now. Let me see here.
So we have a similar question in the chat from Adit. Have you ever faced a cache miss for heavy Gradle task? Say something like during build. If so, how do you catch and address this?
Have you experienced a cache miss for a heavy
Task.
task?
Yep.
I assume heavy in this case probably just means something that takes a long time.
Right.
Right.
And so yeah, absolutely. I think trying to think if I've got like a good example. I can't think of like a good specific task off the top of my head, but yeah, like theoretically, if your build is optimized properly, like if you're building the same thing multiple times without changing anything, everything should be cacheable in an ideal world. So we definitely have had things where before we enabled caching or the remote cache, or before we fixed some of these things, we were seeing expensive tasks related to like Kotlin annotation processing that might be taking a long time, or merging resources, generating schemas. That one I don't think is particularly heavy, but yeah, we definitely seen these things where these tasks are being run all of the time when they don't need to be. Actually, another one is tests. Like we have some tests in some of our modules that are quite heavy. They're generally their unit tests heavily reliant on Roboelectric. So some of them actually take a really long time to run. And so we've seen issues where some of our tests are being run all the time, even if none of the code for that module or anything changes. And so we've worked to try and improve some of that. So the duration or like the heaviness of the task theoretically doesn't really matter that much. Like whether it's a really like a trivial task or a really heavy task, ideally you can cache that. And there are like some interesting edge cases to that. So this gets into something we haven't talked about really, but we've talked about like the local build cache for Gradle. So that is, you run a task on your local machine, whether from the command line or Android Studio. If you then, run that task again, if caching's enabled, it's going to pull all those tasks from the cache if they're not up to date. Like ideally they're just up to date and nothing even runs, but if for some reason they're not up to date, it can pull the artifact from the cache. There's also the concept of a remote build cache where, Adnan, maybe you build something that pushes to the remote cache, and now if I need to execute that same task, I can actually pull the artifacts that you've already built. So there's an interesting issue with this, right? Because now we're talking about a remote cache. So now we're talking about, internet connection and latency and all this stuff. Right. So there are actually times where you might not want to pull something from a remote cache. And this is where, like in particular, if you have something let's say it's heavy in the sense of it's a large artifact. So maybe it doesn't take a lot of like processing power to calculate, but it generates a large artifact. You might not want to actually pull that from the cache because the amount of like latency or your internet connection is slow. It might actually take longer to download it from the cache than it does to actually just build it locally. So that's actually like another sort of like layer of work that we've done a little bit of, and I think we have some more to do. to actually look and make sure that the stuff you're pulling from caches actually is worth pulling from caches. And there's actually another plugin that can help with some of that. So let me share here, and I'll share a couple more resources for these things. So back to kind of what I was mentioning just a second ago about improving, performance of your Gradle builds. So if you're looking for just like what things can I do to start speeding up this my Gradle build, if you want to have some sense of what is out there, this page here on Gradle's documentation, improving the performance of Gradle builds, this is definitely like the first place to maybe go and start browsing. It walks through kind of the idea of a build scan. It talks about some of these easy improvements. So, just making sure you're sort of up to date with like newer versions of Gradle and the JVM. Like there constantly are performance improvements in those, so that can help. We talked about the parallel execution, so that multiple modules can be built at the same time. And it just kind of goes on to talk more about profiling and configuration and the Gradle daemon, and lots of stuff like that. So this is kind of the first resource. And actually, it's worth pointing out too that they have some suggestions kind of for Android builds here. They kind of link you off to like the performance guide and whatnot. But there's some nuggets of good info there as well. So that's one really good option. As I've been mentioning things like the local build cache and parallel execution and build properties and all that, you can get a good sense of what those are by checking out this page. So then the last topic we were just talking about of like, task or build savings and like, sometimes not wanting to actually pull stuff from the cache. There is a plugin called Gradle Doctor. Yeah, Gradle Doctor. So this is maintained by Nilson Osaki, who works at Gradle right now and who also helps work on that other like Gradle Cache Fix plugin. But this plugin is quite interesting because it helps you sort of be aware of and diagnose some subtle sort of issues with Gradle and how it interacts kind of with your project. So like if we look at the features list here, so it can highlight like build speed issues for you. So like one type of thing it can warn you of is if your Gradle build is spending a lot of time garbage collecting. That's an issue that you might not be aware of, but could be really slowing down your build. So if you enable this plugin, it will give you a warning at the end of your build, or maybe it's at the beginning, can't remember, but it'll give you a warning that sort of tells you like, hey, 40% of your build time was just spent because like Gradle and the daemon were constantly garbage collecting, which was really slowing this down. Maybe you should try giving more build memory to JVM and to Gradle. Another interesting one is it can warn you if your network connection is slow enough that it might actually be negatively impacting the performance of your remote build cache. So that's one that my team has integrated because we did a lot of work to make sure our remote build cache is working properly for everyone on our team, regardless of where they are in the world. And we want to make sure that is actually helping them. And so by having this little warning in there, it's just an extra line of protection for that type of thing. And then there's some other ones in here for stuff that like I had never thought of before. So one interesting one is like making sure that Android Studio and sort of your general, development machine are both using the same instance of the Gradle daemon. And so the plugin basically just checks to make sure that, you have Java Home defined, that's being used by both Android Studio and is set in your sort of system environment variables. But there's some interesting things with that. Like if you're using different instances of the Gradle daemon for both of those, then what it means is you might run a build from Android Studio, then run the same task from the command line, but if it's a different daemon, you're not going to be pulling from the same caches. And so like, I know a lot of
Right.
people generally are only building from one or the other, but I'm one of the few people I think that I tend to build from both. I will sometimes deploy from Android Studio, and then I do a lot of builds directly from the command line. So for me, this actually was a big deal because I couldn't figure out why like sometimes, you know, my builds weren't fast, even though I had just run it from one or the other. So this is a really interesting plugin that, again, if you really want to start thinking about how can we kind of put some monitoring and some you know, just start thinking about our build as we're working on our project. Getting this integrated early on would be a nice way to help set you up for that and help detect issues as they're coming. And then it's really easy to integrate as well. So it's another kind of thing where like, you know, not a lot of work. Like this would take you, you know, 15 minutes probably to like integrate into your project. And then you could configure, you know, some of the rules to fit your needs. But a lot of these things actually are quite straightforward. It's enabling a certain flag, you know, integrating a plugin, and it starts to, you know, improve the performance and get you in the mindset of monitoring that performance.
Right.
Yep, makes sense.
Cool. I think now that we spoke of profiling and optimizations and where to start, what to look at, and how what could possibly be the steps that you want to take, right? How does CI fit into the whole all of this, right? And how do you think of CI? Like I know a lot of teams think of CI as a different process from all of these altogether, and they don't really consider it part of the build system because they are like, hey, you know what, this is just another machine building it for us, that is all it is doing. And most of the teams like trying to treat it that way, and I think a lot of problems arise with that kind of a mentality wherein uh, though you optimize it for your local builds, you don't really care about what is happening on your CI server to a great extent, right? And they're like, yeah,
Yep.
that is, you use a third party tool and it is their responsibility to take care of it, and like, or somebody like from the DevOps team takes care of it for you, right? And then uh, how do you kind of look at that in your experience or opinion? What do you think is the best way? Would you like try to make sure everything what you have on local makes sense to be on the CI build as well, or is there a better way of looking at it? How do you go about that?
Yeah. So, I mean, I definitely like. I definitely think that you know, like the build optimizations, like they have a very sort of close relationship with CI, um, because you know you're building the same project. So it, like you said, it is easy to sometimes disconnect them for various reasons. You know, maybe you have a dedicated sort of like DevOps team that is actually responsible for that. So you might not have to think about it. It's also easy to not think about it because you are so used to, you know, you push your changes and, you know, you don't care if it takes a while. I've seen that especially in teams where like if you're not sort of enforcing status checks before merging PRs, then a lot of times people just don't really care when the build finishes, or you know how fast it finishes, or what it reports when it finishes, because you know that's not really tied into the workflow. So I think there's numerous reasons where it's easy to ignore, but the issue with that I see is that, you know, it's actually numerous issues. So one, from just a pure like company, like bottom line, like financial standpoint, is that, you know, CI services cost money. So every time you're, you know, running a CI build, that is costing the company money. So making that as fast and as efficient as possible saves the company money. So that's one reason. If you're looking for like a business case to make to a manager or something for like why you want to work on your build, like that's a good one to make. The second one is developer time. And this one is interesting to talk about as well, because you can say like, oh, well, if developers are, waiting for CI builds, then, that's just developer time wasted. And, and that's totally true. The counter argument to that is like, well, most people don't push a CI build and then just sit around like waiting for it. We push it off and then we jump over to the next thing and we work until it's done, which is a fair point. But there's a subtle cost in that too, in that like now you're context switching. Like if your build takes long enough that you have to, you can't just like grab a cup of coffee and come back. Like you literally, it takes 20 minutes, 30 minutes. Well, now like that's enough time that you do need to go do something else. But now like you're switching back and forth throughout the day. And like there's a cost associated with that, both in, just time and mental context switching. So there's benefits to reducing that time, ideally to a level where you don't have to context switch. Like if your build is fast enough that like you can get up, grab a cup of coffee, go to the bathroom, stretch your legs, like whatever, and then like come back and it's done, then you don't have to context switch. Then there's kind of a third one that I think of that my team, I think right now is sort of starting to get into, in that like let's say you have an automated like deployment process where you kick off some type of release build where you're building your release candidate, maybe you're running automated regressions, whatever you're doing. You want that process to be as fast and smooth and as efficient as possible as well, because you want your releases to be low touch. Like if you have lots of human touch points, if you have an inefficient build, a flaky build, flaky tests, those all introduce points where like your release process can break down, fail, which then again just takes time, it takes money, it's context switching. It makes releases feel painful, it makes them feel heavy, which makes you want to do them less, which then means you're shipping less often, your customers are getting updates less frequently. So there's sort of like a process level and again like customer facing impacts of this as well. So I think there's lots of reasons to want your build to be as fast as possible. And a big part of making it fast then is making sure that your build is efficient. And so that then gets back to the same things that apply on the local build, your caching, your remote caching, your dependency configuration, all of that kind of stuff is chiefly important. Then like, so that part, I definitely think that like devs, if you're not responsible for the CI build itself, you're on a team that has maybe like a DevOps team, you definitely, I think, still need to have at least some thought towards that process as you're optimizing your build, because it is, in a lot of ways, it's the same build. You might want to customize certain things so that the build behaves slightly differently on CI than local. That's totally fine. You want to think about that. But maybe you don't have to think about the infrastructure. That's totally fair. If you're on a team where you don't have that dedicated team, then you're gonna probably have to think about that, or should at least consider thinking about it, because that has a big impact as well. In fact, that's something my team's going on right now. So we don't have a dedicated sort of DevOps team. So we are maintaining our own build. And something that's happened through this process that we've been working through is that we did enough optimizations in our build that our build times went down from something like 45 minutes to like 20 minutes, something in that ballpark. And it got down enough where we started, 20 minutes is like, you start paying more attention, because it's like if you have a really fast build, maybe it's only 15. And so it's almost on that edge of like, you don't have to context switch. So we started like looking more closely at it. And it also means that if you have one that for some reason takes longer than usual, you start noticing it. So we started looking a little bit more closely at the builds as they were happening. And in this process, we discovered that our CI provider at the time, that we were using Travis, which like which works great for a lot of stuff, but I don't think it's like super well optimized for like mobile builds these days. And so what we were finding is that like we would push up a build or push up like a commit, and that would kick off a build, but then that build might sit in our queue for quite a while because of like the plan that our organization had where only X number of builds can be running at a time. So we suddenly noticed like, oh, well, okay, so there's this real world cost associated with just the provider itself and the plan around it. So we noticed like that was adding time to our real world developer wait times. Then we noticed that once a build would start, it has to start up the virtual machine. So it's got to start up the VM, sort of get the initial dependencies going. It has to get that into a runnable, like booted state before it can even start running your build. And we would notice that at times like that would take 4 minutes, 5 minutes, 6 minutes. And so now we started noticing like, wow, like our build is taking 20 minutes of real world wait time, but like 6 minutes of this is just like waiting for Travis to like start
Right.
running the build. And so that was something that like if we weren't sort of like thinking both of like, all right, like which part of this is the actual like Gradle build and which part of this is the infrastructure, we might not have noticed. And so that's actually then led us down this path where we're kind of slowly working our way towards moving our build over to GitHub Actions, where we've seen sort of like another sort of like layer of nice build performance improvements because the VM has more of the tooling pre-installed on it. So we have less time wasted installing things like the NDK. The VM starts up right away. So we're not getting that like weird, wait time at the beginning where nothing's happening. And so just by sort of moving parts of our build over to GitHub Actions, we're now seeing that like our standard PR build, instead of taking like 45 minutes like it did 6 months ago, now with all the caching and everything, sometimes it's taking like 5 minutes. And so now 5 minutes is at this point where like you don't necessarily need to context switch that. Like you can push that commit, open your PR, and 5 minutes you can go check Twitter, get your cup of coffee or whatever, and like reliably know like it's going to be done quite fast. And so that's one of those things. I think like the connection of the infrastructure piece to the actual build itself, I think is important. And then just getting into, like I mentioned, there are ways in which you might want to optimize your build itself for CI. And I think to do that properly, like you do want to have some level of intimate knowledge of the hardware you're running the CI build on. You might want to throw more cores at your test parallelization, depending on how many cores the VM has available. So I think that process also benefits from kind of having your mindset sort of on both things. And then I guess again too, like so that's kind of just like the build itself, but there's like the whole world of sort of like CI and CD beyond just building the process. And then even, there's just generally like automation as well. And if you don't have that DevOps team, again, sort of having that like automation CI/CD mindset is going to help your team in a lot of ways as you start leveraging more of that. So I think there's a lot of benefit to thinking beyond just like what can I do to speed up my build on my machine, but like how can I speed up the build on all of our machines and the CI build, and how can I distribute this more efficiently, and lots of steps kind of beyond that.
Right. So interesting that you mentioned GitHub Actions and Circle CI and Travis CI like that, right? We have been seeing these, right? As you mentioned, like Travis CI, Circle CI, these were the ones which started off very popularly at the beginning, and then with time, everybody started to realize that they are not really optimized for like a mobile specific builds and things like that, right? And have you had a chance to look at something like Bitrise.io, which is like their only USP seems to be the fact that they optimize only for mobile builds. as a option, and versus as you mentioned, right, like GitHub Actions, how easy was that switch from moving over from Travis CI? Do you see any functionality which which you miss, from which is not available in GitHub Actions and things like that?
Sure. So the first question on regarding Bitrise. So I played with Bitrise a little bit a couple years ago. So I'm not super up to date on it. I do know that like I've heard what you said basically. I do believe it to be much better optimized for like modern mobile builds than Travis or Jenkins. Maybe Circle CI as well. It's been a while since I've used Circle also. But so that part I totally believe that, and I've been meaning to go back and give that another look now that I'm much more familiar with kind of CI and automation in general. I know one of the big things that sticks out to me with Bitrise from my memory is that they have like you can do a lot of configuring of your build sort of like in their web interface. Um, and I'm not sure if like you can generate like some type of like static file that represents that same build and like check that into source control. My guess would be that maybe you can, but I remember at one point like that being a little bit of a, not like a red flag or anything, but like it was significantly different from what I was used to of like seeing the build like checked into source control. And so I know like that's like the one main difference that comes to mind is I think that they have a really powerful sort of like, drag and drop editor kind of experience, which I think is probably really awesome, especially for like first time, like if you're not super familiar with like scripting and stuff. I think it's really powerful. I'm not sure how I would feel about it for like my everyday production build. But I know that it's totally capable because I know teams that have used it and whatnot. So yeah, I've been meaning to get back to Bitrise. In terms of like GitHub Actions and like the functionality it provides and whatnot, I have found GitHub Actions incredibly easy to get up and running with because it basically, like the whole idea of GitHub Actions is that it sort of packages like little scripts and little bits of functionality in these easy to reuse containers. So like in our Travis build, for example, and this is indicative of pretty much every build I've ever worked on, there's all kinds of like little tiny custom scripts that, tag your nightly build with your custom tagging behavior, or maybe it, bumps your release number based on your concept of semantic versioning, like all these little things, right? And, if you're not familiar with CI, you're not familiar with scripting and whatnot, all of that stuff becomes like really overwhelming. Like when I first looked at a CI script back in my first job, like I had no idea. It was like I saw all these like shell scripts and Python scripts and all this stuff, and it's like I'm just going to close this file. Like that's just the part of the code I don't want to deal with right now. And so like that's one thing I love about GitHub Actions is that like it basically becomes like connecting Legos in a sense. Like, oh, I need caching. I'm gonna grab the caching action and stick it in here. And I want to execute a Gradle command. Oh, there's an action that lets you basically grab any arbitrary Gradle command and will automatically deal with, making sure that the caches and all of that are saved properly across runs of the VM. So it makes composing different functionality super simple. And I think because of that simplicity, it's hard for me to want to go to anything else. Maybe something like a Bitrise where it kind of has, I think, a similar concept where you're like kind of, building your flows in the editor. So I think that would probably be similar in terms of approachability. But I love that like you can hand someone a simple Android build with GitHub Actions to someone that hasn't really looked at it before, and like it's very understandable, and I think it's a lot easier to give that to someone and have them start like hacking away at that and customizing it than it is with some of the other providers. And I think that like that's made additionally easy by two things. Like GitHub Actions has their marketplace, which is really powerful. In fact, I have that up. So yeah, like the GitHub Actions marketplace here, where you can just like search for anything you want. So like, let's say Firebase, and like, if you want to automate something related to Firebase, here's 32 different actions that you could use. So, like Firebase app distribution, like setting up Firebase app distribution for your project with like GitHub Actions is super simple. You add like 5 lines to your workflow, and then you basically add a token to your secrets within GitHub, and like you have distribution set up. So it just makes like finding this stuff, using it super simple. And then the other thing that's really nice about this is like, if you trying to think how to do this. So if you want to add a new workflow, it's really easy. I think, can I do this? Yeah, create a new file, test, and test that, just YAML, I think. Actually, I can't remember how to get it now. There is a way to sort of like edit your GitHub Actions workflow within GitHub itself, and actually like sort of pull in those actions from that marketplace as you go. Maybe if I edit, yeah, here we go. So here I have a pre-existing workflow set up, and I hit edit. And so now like it's letting me like pull actions directly from here. So like if I click on setup.NET Core, like right here, it gives me the example snippet that I can just copy and then go and drop over into my workflow. And and it has documentation for it to sort of like help you understand like how the file is structured and all that. So again, like that stuff I think makes getting started with GitHub Actions really, really easy. And so anyways, yeah, I have found that like, at least for me, it gets me into this like automate all the things kind of mindset where, like before, like in, let's say like the Travis world, it would be like, yes, I know all of this stuff can be automated, but then I have to write the scripts to do all this stuff. And so like, it just becomes this much more expensive prospect. But with GitHub Actions, it's like, yes, it's all possible, and a lot of the building blocks are already there. We just need to compose them in the proper way and send the notifications in the right places and whatnot. And so I just feel like at least on a couple different teams I've been on now, it has enabled us to be much more forward thinking in terms of like how much stuff can we automate here? And again, just beyond even just the build, like, a lot of times you start thinking about like CI initially as like, we want to run our tests, we want to assemble our app, and like that's maybe the extent, and maybe distribute it to testers or even to the Google Play Store if you're sort of like really starting to automate things. But like in my last company, my coworker, Ryan Harder, and we actually used GitHub Actions to sort of process static content for our app that served basically what was on our homepage. Like the homepage of our app was sort of very sort of like image focused. It was a coloring book app, so it had like pages and coloring books, and we could serve that content from sort of a static URL. And so what we did is we were able to automate the process where before our other people at the company, they would sort of like generate what like that homepage layout should look like. Then they would manually like run the script. They would turn that into basically JSON served from this URL. We actually used GitHub Actions where we could like go and make a bunch of versions of that, and then we would like every day run a workflow that would, it's like, oh, get today's workflow, run the script, upload it to the thing. And so it basically let us automate all of that process with a very easy script. And that's something that, again, we totally could have done beforehand, but just like GitHub Actions and its functionality made it so accessible that it took it from like this idea to something that we could kind of prototype in an afternoon and get working within, a week or something. So I love GitHub Actions for that reason.
Okay, so is there any resources maybe you can recommend for the people who wants to start with GitHub Actions?
Yeah. So I don't always love to plug my own stuff, but I do like I have given a couple sort of like talks and videos recently on GitHub Actions. So one, again, I'll share my screen here. So one was this talk I just gave at Chicago Roboto. Whoops, and we don't need ads. We'll say goodbye to the Muppets. Anyway, so this video, building an Android CI pipeline with GitHub Actions, on my YouTube channel. I did a similar video. Actually, I've done a couple similar videos. So here's another one: set up CI for Android apps using GitHub Actions. So there's a couple of videos on my YouTube channel about GitHub Actions. The documentation is actually quite good as well. So it's like docs.github.com/free-pro-teams@latest/actions. Basically search GitHub Actions documentation, and they've got a quick start guide here. They have stuff, about setting up with templates. The workflow syntax, I think, is really helpful here, because it starts breaking you down line by line of what you see if you're looking at a workflow file. So it gives you examples of like the actions here. So you have like push and pull request. And then it starts showing you how to compose these things together, so that you can say, on a push to this certain branch or a pull request against this certain branch. So this, I think, is actually a really interesting spot to explore as well. And the left-hand side of the docs here breaks down into a lot of different examples and documentation. There's one interesting one I like to show, which is the triggers. Let me see if I can find it real quick. So this isn't it, although this is another good one. So when I've talked to teammates before, there's often this question of like, well, what can trigger an action, or like how can we run a workflow on GitHub Actions? And so there's a few ways of like triggering a workflow. So you could have workflows that trigger in response to an event. And the list of events is what I was trying to find. Oh, actually, maybe this is the right page. So basically, like you can have it respond to an event like a push or creating a pull request, or really a lot of stuff. So if we look on the right-hand side of the screen here, this list of webhook events here,
Right.
like these are all the different triggers that can start your event. So, pull request review comment can trigger a workflow. Creating a release draft. Like I think it's not too outlandish to say that basically anything you do within GitHub can trigger a workflow. That might not be technically correct, but like it's probably getting pretty close. So that's all the trigger, or the webhook triggers. But then you can also do things like scheduling events. So this makes things like your nightly build really easy. You could set up something that like once a week checks for new dependency versions and notifies the team. We used a scheduled event here when I was working with Ryan on that sort of automated static content generation. And basically this just works on like simple cron syntax. So, you can tell it, basically run this workflow on this schedule. And then from there, you define your workflow as is. And it's going to manage all that infrastructure for running the cron event for you. And then there's actually, there's technically two different ways of like manually triggering an action. I wrote a couple posts about how to do it the old way last year, and then thankfully they introduced something a little bit more first party, specifically for GitHub Actions. But there's this concept of like a workflow dispatch event where you can actually tell a specific workflow like, hey, I am meant to be run manually, and you can even configure it to take inputs. So one example of this is maybe you want to be able to send like any arbitrary build to Firebase app distribution, and you want to be able to give it like a custom label so that you can find it within Firebase. You could have an input for that label where the person could type it in, click run workflow. It's going to run that workflow, grab that environment variable, stick it into the APK, and then upload that to Firebase when you're done. And that, I think we might be able to show that. I think in this repo, I have a lot of examples. This is I have this repo called GitHub Actions Automation Sandbox, and I've been using this for different talks and whatnot I've been doing. So there's a lot of different examples of workflows and whatnot in here. And I think I have one here called workflow dispatch example. So when you have a workflow dispatch workflow enabled, when you come view it in the Actions tab in GitHub, you'll see this little drop down here that says Run Workflow. So if you click on that, you can choose which branch you want to run this off of, and then here I have this version suffix. So I could type whatever I want in here, and then when that build is processed, it's going to use that to give that version of the app a unique suffix.
Right.
So anyways, yeah, like those are like the kind of the three main ways of triggering. But then you start thinking of all the different webhooks and everything. You can really trigger your actions off of pretty much anything you want to end up doing within GitHub, which is again really cool and kind of opens up this whole world of possibilities that integrate so well with what you're already doing in GitHub, which is another reason I like GitHub Actions. Not everyone's working in GitHub. I know some people are in GitLab or in other things, but if you are in GitHub, it's hard to beat the integration because things like authentication with tokens and whatnot, like that's just kind of handled because you're already within the system. So it just like simplifies a lot of the things you would otherwise have to do.
Right. So there's another question in our chat. It's from Adit. How do we optimize a stage job which involves heavy CPU utilization? Not many on the team would ideally be aware of something like Kubernetes. Any tips from your experience? I think it's not related to GitHub Actions. It's probably hosting a CI server on a Kubernetes.
Yeah, I don't really have experience with the Kubernetes there. I think the best answer I could give here is that, like anything, you can't fix what you're not monitoring and measuring. So I think the first step would be able to have tooling in place to be able to monitor that, to be able to actually monitor and identify the CPU bottleneck, and to be able to hopefully profile that in some way and figure out where the bottleneck comes from. So I think, figuring out how to get to that point, then figuring out maybe can I automate this workflow that I took to figure out that there is an issue here, and then hopefully set up some type of alerting system, so if you're reaching that bottleneck in the future, you can be notified of it. And then going back and trying to fix it to begin with. And how to actually fix that within, Kubernetes, I don't know. I'm sure, given that ecosystem, I'm sure that is somewhat of a solved problem. I'm sure there's some type of tooling out there that, could be used to help with that to some extent. But I don't know.
Cool. I think, yeah, we have already crossed our over time as well.
Oh, wow.
So,
Yeah.
yeah, it's interesting. I think, yeah, for now, we can, this should be good. Thank you for taking time today to talk to us. I know it was early Saturday morning, your time to try and get this done. So, yeah, thank you very much. Hopefully, I
Yeah.
hopefully I run into you in a physical conference soon.
I hope so. I hope real in-person events come back again soon. But yeah, no, thank you both for having me. This was a lot of fun. And yeah, if anyone, if there's anyone in the chat or anything that have questions, feel free to reach out. And I don't know if you guys sort of distribute show notes or anything, but if so, I could share links with those so that the audience can find some of these resources too if they want.
Yes, yes. We have a Discord server where we usually distribute our show notes.
Okay, cool. Yeah, we can definitely share all these links then.
Thank you. So I'm going to end the stream.